left off at number...
Finish 2.
Oh, so we left at number 3, okay. So you guys, are you aware of Math 178? It's like the light version of calculus.
Business calc?
Business calc, exactly. So it's straight up applications. You don't have to take pre-calculus before you take it, although it's highly recommended. What kills people in that class, and sometimes this class, is an inability to factor. So this happens more often than you might think in calculus, because the method we use to do things in calculus. We get something like this, and you have to be able to factor it so you can see where it's 0, because very often setting things equal to 0 gets you to interesting places. So for example, if this is my profit function, say that's my profit function, where does my company want to be? If that is your profit function for your company, where do you want to be? You want to be right there. What's special about right there? What's the slope right there? 0. So calculus is all about doing something to figure out the slope, not just of straight lines. That's algebra. Straight lines are easy. What's the slope? It's the same always, so just find it once and you're done. What's the slope of this? It's changing. Every instant of time it's changing. Are you with me?
Yes.
So what's the slope here? Positive. And the slope is getting smaller and smaller until it's 0. It's flat. And then it's getting bigger and negative. Right? So, does that make sense? So we'll do calculus to an equation that represents profit, and we'll set it equal to 0, because that will tell me where the highest point is. Hopefully, you got to be careful it's not the lowest point, right? Because it can't differentiate between this or that. You have to be able to differentiate between the two of them. Are you guys kind of semi with me? That's obviously not, I'm not teaching you calculus. I'm telling you what calculus will do. I'm not teaching you yet. So this would lead to that idea. How do you factor this? So some of you guys started to multiply that out. You almost never multiply on the way to factor because it's the opposite of each other. So you really just use GCF, right? So what number comes out? 3. How many m's come out? 1. How many n minus 5's come out? 3. Yeah, so n minus 5 is just like y. It's just another variable. It just happens to be longer than I'm used to. n minus 5 is a variable. Right? Whatever m is, n minus 5 is another number. So you can take 3 of them out. It's always the smallest power that I see, right? So then what's left in this first term? 2m. None of these. Minus 7. How many of these? One of those. Now here's why I said almost never multiply, because now just to simplify the inside, you're going to distribute, right? Is that cool?
Yes.
So I have to cover my ass on that. I don't want somebody to go, you're multiplying. No, simplify, I'm going to multiply this out. So you get 3m, m minus 5 cubed. 2m minus 7m is negative 5m plus 35. And then the last thing now, you can take out like a negative 5, for example, right? So you get negative 15m, m minus 5 cubed, m minus 7. So you guys see that last step? Take a negative 5 out of here. So that becomes negative 15 out there. You guys all right? Some of you guys are looking at me like, what is this? All right. Let's see. So number 4. So I warned you guys about trig. So you have to do the reference angle work just to see. Cosine. Nicholas got Gorilla Glass. Oh. Okay. Oh. That's a major fail. Okay. Poor little dude. Alright.
It looks like a cute tiny robot.
Whatever gets you through. Sorry. Alright. Cosine, thank you. Alright. I think I had cosecant there first, and then I decided to backtrack a little bit. So what do you do first? When I say show your reference angle work, you just do a quick little thing like that. So 6 pi over 6, of course, would be pi, which we all should know is 180 degrees. and then an extra little pi over 6. Now, you shouldn't have to, but if you do change it to degrees, okay, but you really shouldn't have to. You should have come out of pre-calc with an understanding of radians and working directly with them. So when you see pi over 6, how many degrees is that? 30, because pi is 180 divided by 6 is 30. Yeah, so that's 30. It's a little bit past it. I really, don't get me wrong. If you know this, you can continue to use it. It's fine. I want to see if you guys understand. SOHCAHTOA, I wish it would go away. Does anybody know SOHCAHTOA? All right. The reason I don't like it is because it only gets you so far. What they should teach you is the reality that sine likes y, cosine likes x. What's the definition of sine? Do you remember? Sine of an angle is y over r, isn't it? Or y over h, if you call it hypotenuse. Yeah. So sine likes y, cosine likes x. So of course, where I'm on the x-axis at 0 degrees, cosine's going to be the biggest. Because cosine loves x. Oh, yay, I'm 1. Sine's like, oh shit, I don't want 0, right? And I don't know, have you ever noticed, real quick thing, I've got all these little things about trig, it's really neat. What's the pattern here? It's like sine of 0 degrees is what? 0, because sine likes y. At 0 degrees, it's all x. No piece of the x-axis is y. So that's 0. At 30 degrees, pi over 6. What's sine of pi over 6? Now it's a little bit y. Good, it's a smaller possibility. Why? What, right? 1/2. So isn't that square root of 1 over 2? Let's go with me. Isn't it 0 squared to 0 over 2? Go with me. Yeah. You guys are like, sure, man. Sine of pi over 4. We're at 2 over 2. What's sine of pi over 3? We're at 3 over 2. Well, what's sine of pi over 4? Pi over 2. Rad 4 over 2, which is what? Rad 0, rad 1, rad 2, rad 3, rad 4, all over 2. It's a nice pattern. And what does cosine do? The opposite, because it starts off big and gets small.
We just did math.
Sorry? Yeah, we do math like almost all the time. In here. You guys with me? I don't know if you guys have a way to memorize it, but I didn't really memorize it. I just kind of think about where I am. If I'm close to the x-axis, cosine's big, sine's small. You with me? And then, of course, all these are just negatives and positives thrown in the right place. All you need to know is the first quadrant. All right, that is trig class. Yay. A little more to it than that, but that'll get started. So here I am. I know what the cosine of pi over 6 is. What's the cosine of 30? It's close to the x-axis, so cosine should be bigger, so it's got to be the rad 3 over 2 option, right? You guys with me? Yeah. And I'm in a place where x is negative. See, that's why SOHCAHTOA sucks. And if you like it, it's fine. It does well in a few things, but it's so much better if they would just teach you that cosine is x, sine is y. Because now, to remember what's positive and negative, you just think, what's x? X is negative back here. So cosine, of course, is negative in both of those, because that's where x is freaking negative. Sine is negative down there, because sine likes y. That's why y is negative. It's just silly to me. So then what's it going to be? It's going to be rad 3 over 2, but because I'm there, it's negative rad 3 over 2. I like it. So trust me, if I build a problem with these known angles, I better not get decimal freaking answers, right? I want exact answers. Does that make sense?
Yes.
So don't give me the decimal, because I'm like, that didn't come from you. Screw that. Okay, how we doing? All right. Holy crap, guys. You're in like poker mode. What's going on? We're not playing poker. I got nothing. All right. 4b. So here I gave you some degrees just to change it up. And it's negative, so of course that means what? Go the other way around. I like it. So how much past 180? 45. 45. So the reference angle is 45. Here's your reference angle word, right? Tangent is sine over cosine. So tangent, sine and cosine, if they're opposite signs, tangent's going to be negative. Right? So in this case, the tangent's going to be... Yeah, so be careful now. If tangent is sine over cosine, at 45, what's true about sine and cosine? They're equal. So, of course, tangent is going to be some kind of 1, right? In this case, it's going to be negative 1. So what's up? Everybody all right? All right, maybe. Yes, sir.
Instead of just going backwards, could I just add 360 to that and then go?
Totally, yeah. You'll still end up in the same place, right?
Right.
So you're finding the positive coterminal angle, right? Which is another way of saying you get to the same place. So if I ask you to turn this far around, you can go, that's good, I'm just going to turn not as far, just stay in the same direction. Like, whatever. All right, I like it. Good. So any other little things you do differently is fine. I just need to see that you understand how trig works. Not that you understand what buttons to press or something like that. Okay. All right. So anything, we finished that sheet. Was there anything from that sheet that you wanted more on, or anything from homework, hopefully, that you started? It's up to you. Today was the day to come with questions. You can never ask any more questions. No, you can, yeah. 10. Oh, the one they gave you the graph? And you had to draw the... Okay, all right. So let's remember what happens here. So the idea is transformations of functions, right? Picking a function up and moving it around. Or making it skinnier, wider, reflecting it, all those things. Remember those? Pre-calc should have done a lot of those to you.
Good times.
Yeah, good times. So let's give us a specific function for a second. Square root of x. Can you draw that in the air for me real quick? What's square root of x look like? All right, good. I like it. Most of you guys, some of you guys are like just. All right. There. What would this do to that? Here's an easy one. What would this do to that? Oh yeah, all the outputs, what they used to be, are now one bigger. So effectively, visually, it's just going to pick it up by one, right? So now this would be starting at 1, and then whoop, everything just goes up 1. Easy. So what does this do? Let's call this F. Call this G. Call this H. So what does this do? Because if you think about it, what's the smallest the inside can be to still be real? The inside of a square root can be 0 and still be real, right? Yes. But the fact that I'm adding 1 to my inputs allows my inputs to become 1 smaller than they used to be able to be. Right? Ooh, try the grammar out in that sense. So, like, I used to only be able to plug a 0, and that's the smallest I could plug in. But now the fact that I'm adding 1 to what I plug in, now I'm allowed to plug in a negative 1. So that's why when you first learn this, hopefully this is not true anymore, but when you first learn it, it's weird that you go back when you have a plus sign. But it's like you're acting against this, or this is allowing you to do more than you used to be. If I'm subtracting 1, I've got to work again. Oh shit, I better make everything 1 bigger, so that when I subtract 1, I'm still legal. Right? You guys understand? All right. So that would take, let me see, what's another color? Let's make it blue. So then this would take it from here, it would go back 1, and it would still be the same shape. I like it. All right. Please, dear God, this is not good enough for homework, by the way. This is good enough for me explaining to you how things work. Do not give me this as an answer to homework. Scale, some work, you got to show me something, right? All right, but that's the idea. Is that cool? So on this one, it's a little different, but not really. Here I give you a function, you know what it looks like. On this problem number 10, they don't even tell you what the function is, but who cares? They give you the picture. It's roughly like this, right? Oops. It's like that, number 10. And then they ask you, for example, the first thing they say is, if this is f of x, like square root of x, but it's obviously not that, then what is f of, what was it, x minus 8? What would that do? It's just like putting a minus 8 here. And move it to the right, 8. So you just take this same picture and you pick out a few key points and you just move them all right 8. Is that cool? Does that make sense?
Yes.
All right, and then they give you like what would this do?
Division.
Yeah, all the outputs are now half. So that would go to here, that would go to here. Right? It just cuts everything, so it just smooshes everything. Right? And if you put a 2 out front, it would just elongate everything. Remember the compression and what was the other one? Elongations, expansion, whatever. All right. Is that cool? Is that all right? Who asked that question? The freaky one is if I do this, what would this do? If it's with the letter, it does the opposite. We know that already. It does the opposite of what it looks like. So it doesn't cut the x's in third. It actually lets the x's become 3 times bigger. Because all my inputs can now be 3 times bigger than they used to be, because the first thing I do to them is cut them in thirds, right? So it would take this and stretch it out. That would now be 1, 2, 3 times bigger. Do you guys? No? Oh, shit, don't tell me you're going to be that kind of class. Come on.
I get it.
I get no reaction. I can't gauge you guys at all. Try to read me. Damn. All right. Let's see. Is that who asked that question? Is that decent? Who asked that question? Somebody. Okay. Thank you. I was like, somebody asked me. I didn't just make that up, did I? All right. Anything else from that first homework?
23.
23.
Yeah, I'm kind of confused.
Oh yeah, this one. This is what I think is the hardest problem in here, but then it becomes the easiest one once you realize how you have to look at it. So number 23. Did anybody else try this one? Number 23. It's open up. And I want you to find f inverse of 2. So if you try to find the inverse function, you might drive yourself a little insane. So maybe don't do that. There's a different way. So what does this mean?
Why is it you have to change the place?
So if f of x equals y, what's f inverse of what equals what? Yeah, so for inverse functions, the domain of the original becomes the range of the other one, and vice versa, right? You switch the x and y to find the inverse. You guys remember that? And the beautiful thing is, visually, what do? You switch the x and y, and you replot the points, and you get the inverse. So that basic idea of switching x and y, switch the range and domain, there you go. It goes throughout all of it. Switch x and y.
Yeah, but when I try to do that...
Don't do that. Because you can't. You can't get this guy's inverse. It's not easy. It's very, very, very crazy. So what you think instead is, what is this, thinking about this, what is this really asking you? F inverse of 2 equals what x? So undo the inverse. Is that a weird thing? Go back. What would this look like?
F of x.
Yeah, so you're thinking to yourself, what value of x makes the output 2? That might make this a little easier. Maybe. So this is less algebra computation. This is more just look at it and see what works. That's why this is a hard problem, because you don't realize that's the way you got to do it. What value of x makes this 2? And what's the ln of 1? 0. So what's f of 1? 2. So what's the answer to this? No. 1. What is this asking me? It's asking me what x value makes the output 2. That's another way. That's why I said write it like this. So what x value makes the output 2? 1. Which means f inverse of 2 is 1, because f of 1 is 2. You guys decently comfortable with how inverse functions and original functions work? All right, one guy's output is the other guy's input, and vice versa. All right. Still getting a few looks like I'm insane, but at least that's a readable reaction. I like that. You can look at me like I'm insane. At least it means I can tell what you think. No? Yes?
Do they have any of those examples in the book?
Probably not. But you're getting to the point, especially in pre-calc, you should have been used to this. You got to understand that there's going to be concepts, and there will be applications of those concepts. There's too many applications to possibly have them all represented. The book would be bigger than this, and would probably cost a lot of money. So, something I really hate, but I understand, is when a student says, your test was nothing like the homework. No, my test was exactly like the homework. It had exactly the same concepts. Oh, some of you guys are like, oh, you're that kind of teacher. Oh, you suck. But this is calculus. That's what the way calculus is. This is the way actually all of math is. And now that you're in calculus, I can tell you this, math starts at calculus. So I need you to realize that. Math starts at calculus. Everything below calculus is just learning how to crawl. Math starts at calculus, right? When I took calculus, I was kind of upset. I wanted to teach high school algebra. That's what I wanted to do. And I thought, what do I have to do calculus? And then I was like, you get further and you're like, how did I do anything before I knew calculus? Holy shit. And you have no idea what comes after that. So right now, some of you guys think you know what math is. You have no idea what math is. None. You get calculus is learning how to walk. And then you do real math, right? Sorry, I don't know if that helped you or whatever it did for you. I just had to get that out there. So my tests, I don't make them freaky, I don't make them, but I will have problems that ask you to use things we learn in ways that might not be exactly the same as any problem you've seen, because that's not the way this works. I'm not going to just give you cookie cutter problems. That's bullshit, right? So, okay, maybe. There will be processes you use. If I ever say find the maximum, for example, there's a process you use. So will it be sitting in a problem that you've seen before? No, but you identify, oh, this problem wants me to find the maximum. Okay, I know what process to use then. Right? That's the kind of thing. All right, maybe. I just made some enemies, but oh well. I'm a math teacher, I'm used to it. Okay. So I forget something? A question? Oh yeah, that was the last question. Any other questions from homework stuff? Was it all right? Did it go okay? Some of you guys are like, I haven't done it yet, but I'm going to tell you yes. All right.
Maybe 20.
Second?
20.
20. Oh yeah, good. All right. So let me first do one the other way. All right, F, G, and H. There they are, right? This notation, I kind of hate this notation, but do you know what this notation means? It's not full hog. That sounds weird. F of H of G. So a better way to write this, I wish they would have never made this stupid little notation. F of H of G, and then it's really clear what's going on. You want to take G and plug it into H, and take that and plug it into F, right? So take a minute and try to figure out what that is. It's like Russian nesting dolls. You just got to put them back together. And then the problem you're asking me about is doing this in reverse. Exactly. So this is going forward. I gave you the functions. I want you to write what the result is. The question you're asking me about is they gave you the result. They want you to tell me what those are. So I got to start here. If we're not able to do this, we'll never be able to do that. So don't go too insane here. Don't cube that bad boy out. All right. Don't drive yourself insane. Just is everybody cool with that? So that's what G is. G is that. I'm going to plug G into H. So I'm going to cube this. Don't cube it though. Just don't cube it. All right. And then what am I going to do with this? Plug it all into there. Okay. So that's forward. They give you the pieces and you put them together. Number 20 gives you the end result and asks you to break them back apart. There are actually an infinite number of answers possible here. So it sounds like you can't go wrong, but it's still just a subset of all answers, including the wrong ones. There's a bigger infinity of wrong answers. Have fun understanding that. So they give you this end result. They say big ass F is 1 over the square root of x plus the square root of x, like that. Nested radicals. Now, do you see the outside? What would you say is the outside function of what we just did? What's the very outside function of what we just did?
1 over x.
Yeah, exactly. What's the outside function? What's the main function there? 1 over x. Do you kind of see what I'm saying? Isn't the main idea of this thing 1 over something? All right, I like it. Start to unpack this thing. So you could say, I'm going to write this in terms of f. Let's just say f of g of h is put in alphabetical order. Right? Is that cool?
Yeah.
So I've identified f is probably 1 over x. Now what did I plug into that? What form is this in?
Square root. X.
Now here's where things get weird, right? Now, yeah, to be honest, there's an easy answer for this. There's like, you can call one of your f, g, or h, you can call it x. I don't know if you guys understand how that makes things easier. Just call it x. But if you got to be careful what you say here. Maybe it's easier to say what h is. What would you say the very inside function is? What's the most innermost function?
X plus square root of x. Square.
Yeah, okay, that'll work. X plus the square root of x. Sorry, that just wasn't what I was thinking. I'm like, wait, that'll work too. And then what's the g got to be then? I love it. So if you plug this into this, you'll get that. And if you plug this into this, you'll end up with 1 over that. So maybe try to come up with a different answer. Or not. Everybody's going to have this answer now. Oh well. You did it to yourself. There are many answers to this. Some of them are kind of dumb. You can have a piece of it, subtract 1, and then add 1 and do stupid things like that. But some of them involve x squared and something's square root of x, so when you plug it in, you get a full x and stuff like that. I mean, there's other ways to play with this. But you guys, it's really a weird question when you first look at it, you're like, I have no idea what they want me to do. But this is what they want you to do. And the reason I like this question is a lot of calculus involves what's the outside function, what's the inside function. And if you take the calculus before, you might know what I'm talking about. If you haven't, we'll get there. How are we doing so far? Is that all right? Okay. Everything I say seems to beat you down. I'm sorry. I don't need to do that. Get it done. So, anything else in that first chapter homework stuff? From anyone who did it? Yes?
24.
Which one, sorry?
24.
24. Yes. So let's tackle a simpler problem first. How do you find, we said this already, but how do you find the inverse of any function?
Change the basis.
And how do you know there's an inverse function to this besides I just said there was? Anybody know how you know there's an inverse function for this? What would it look like if you graph it? Can you draw it in the air? Oh man, everybody, I know some of you guys are like, so it looks cubish. It's been moved down 7, but it looks like this. Right? Maybe not that flat in the middle, but that's the basic idea. So what test does it pass that allows it to be invertible? Vertical line test means it's a function. Doesn't mean shit about invertibility. Probably the horizontal line test. And why is it, I really want this to make sense. A parabola is a function. It passes the vertical line test.
Yes.
If I try to invert it, is the result a function?
No.
No. So instead of actually inverting it, I just make an inversion of the test. Vertical tells me it's a function. Horizontal would be the vertical here. Are you kind of with me?
Yes.
So instead of doing that, I just say, no, let me just apply a horizontal line test instead of actually turning the damn thing around. Do you guys understand? Did you know that? That's why there's a horizontal line test? A volt and a hilt.
Yeah.
All right, so that would definitely pass the horizontal line test because it's not that flat. I mean, it just flattens out for a second, and then so everywhere the vertical line, horizontal line only goes through once. Therefore, it's invertible. How do I invert it? Yeah, where's y? That's y, right? So bring y back in, and then do what?
Change the places.
Change. So I always draw like a little dotted line just to say I'm doing something weird. Because to go from here to here, can you do algebra to go from there to there? No. You're applying an idea, right? From here to here, I didn't add 2 to both sides. I did something freaky. I applied an idea. And now what do? Solve for y. And it makes sense, because in the process of solving for y, am I not going to do all the opposite operations in the opposite order? Yes. That's the whole idea of solving, is to do the opposite operation. So I'm going to add 7. I'm going to cube root. So there's the inverse function. Add 7 cube root. So instead of subtracting 7 first, last, it adds 7 first. Instead of cubing first, it cube roots last. Opposite functions, opposite order. So, what about the actual question? Whoever asked the question, like, That's nice. What about the thing? Yeah. What I asked. It'd be nice. I'm not saying that's what you sound like. Sorry. Can't remember who you are. So, the big thing for me recently when I'm teaching 91 and 3110, so I'm trying to get them to understand, bless you, the processes in math never change. Just the things inside that I'm applying the process to changes. The process I use to find the inverse function doesn't give a shit what the function looks like as long as it passes the horizontal line test, right? So what's the process? The process, again, doesn't care. So what's the process? Switch, that's y, switch the x and y. So I get x equals y plus 1 over 2, y plus 1, right? And then I solve for y. How do I solve for, how many y's are there?
2.
It looks like there's 2. There really isn't. But anytime there's more than one variable that I'm trying to solve for, what the hell do I do? So what's the very first thing I definitely want to do? Yeah. I got stuff on the bottom. Screw the stuff on the bottom. Bring it up here. So I get 2xy plus x. Is that cool? Multiply that up?
Yeah.
Makes sense because now everything's free to move around.
Yeah.
So what do you do when you're trying to solve for a variable? Don't you get all of them on one side? So what do I want to get on one side? I want to get everything that has a y in it on one side, and I want everything else to get the hell out of the way. So I get 2xy minus y equals negative x plus 1. Let me stop there. So I got all my y stuff on one side, everything else on the other side. This is what we've been doing ever since you first learned how to solve solve equations. You doing all right? And then here's what I meant by there aren't really two y's because one y comes back out. There's only one y that was distributed to two things. Evil little thing. Might as well write that as 1 minus x, and then you can just divide by what you don't want. Divide the 2x minus 1. So f inverse. Let me see if you guys remember pre-calculus. Oh shit. What is the vertical asymptote for this? Vertical asymptote. Yes, negative 1/2. There would be a hard wall. You know, he draws a dotted thing, but you can't, pull up. You can't go through that wall, right? Because the domain says you can't be negative 1/2. Too bad. What is the horizontal asymptote of this? How do you find horizontal asymptotes? If the powers are the same, it's the... So the horizontal asymptote... So here, let me do this. The va is negative 1/2 because the vertical asymptote comes from the domain. The ha is when x gets really big. What do you have to do? That's why you can pass through the ha as many times as you want to because it just means what do you have to do when you get big. So the ha, they're both powers of 1. So what's the ha? The ratio of the coefficients, right? Remember that? 1/2. Oh, do you guys remember that? You can be honest.
I didn't remember that.
So I don't know if you remember the long way of doing it was to take this and divide by the highest power of x you see. Because when you let x get really big, what does 1 over x do? If x gets really big, 1 over x gets really small. So it goes to 0. So that's why it gets to 1/2 when you let x get really big. Does this make you remember? Anybody remember this?
How did you find
I want to give you a little clue.
Again,
This is huge. Yes?
How did you find the vertical asymptote again?
Oh, it's just what x am I not allowed to use?
Oh.
So what's x makes the bottom
where
0. And then you'll set up a hard wall at negative 1/2. So the function's got to slam up against it somehow. Either like that or like that. Right?
Yeah.
That much you remember, right? So horizontal asymptotes were all about which one wins, the top or the bottom. So if the bottom has a bigger power, it wins. It makes the whole thing go to 0. I'm dividing by bigger and bigger, so you go to 0. Nah. If the top power is bigger, it's actually slant asymptote, remember? But it goes to infinity. There is no ceiling. It just goes to infinity. The top is bigger, the bottom can't contain it. I go to infinity. If they're the same power, they're kind of lockstep, and they agree on something. So here, they're the same power, so if I let x get really big, 1/2. Maybe. Did you anybody's teacher write that like this? As x goes to infinity, y goes to 1/2.
Yeah.
Does that look familiar? So no, all right. But do you understand what that means? That's what horizontal asymptote is all about. When x gets really big, positive or negative for that matter. When x gets really big, either direction, what does the function do? And that's related to end behavior. Remember that term, end behavior? End behavior. Good. The way we're going to write it is something about this. The limit as x goes to infinity of the function is 1/2. These all mean the same thing. This means the same thing as that. This is just a little more technical way of writing that. All right, that's the first part of chapter 2 is about these weird things called limits, but you've already done limits. When I taught pre-calc, I tried to use this notation so they were ready when they got to calc. All right. So my point is, let me come back to my point. The va, this is negative 1/2, the ha, this is 1/2. What's the vertical asymptote of this? Let me write it again here, poor little dude. What's the vertical asymptote? Bless you. Careful. Positive 1/2. And what's the horizontal asymptote? No. Negative 1/2. So what happens? Of course what happens with functions and inverse functions? The x's and the y's switch. These are x's, these are y's. They're related. So they're going to switch also for the function and the inverse function. Every x-related thing will switch with the y-related thing. Bam! It's kind of neat to see. It's unfortunate that they're almost the same. Thankfully, one of them is negative. So here the va was negative, here the ha is negative 1/2. They switched because they're inverse functions. Is there anything else before we get into a little bit of chapter 2 stuff? Yes? Oh, good. Yeah, this is going to become very important. Oh, let me push this. It's a little bit more than what they've got down there, but I just want to show you where this came from. Say I had a function that goes through that point, and it goes through that point. Right? And I want you to figure out what's the slope between these 2 points. Straight slope, like a crow, as the crow flies. If the crow's not drunk or something. Tipsy crow. Straight line, right? How do you figure out the slope of any between any 2 points?
Y over x.
You can't lose. Rise over run. Rise rhymes with y's. Y's on top. So what is y2 minus y1? What's the y2? Here's let's say this is the first point, right? This is the first point, this is the second point. So what's y2? F of a plus h, right? That's the output for it. So f of a plus h minus, what's y1? F of a. That's how much the y's changed, how much it rose, how much did it run. A plus h minus a. So the a's cancel and you get the expression they're talking about in this problem, right? I just want to show you where that, they call it the difference quotient. It is just the slope between 2 points on a function. Does the function have to be a straight line? No. You're just getting the straight line between 2 points on that function. How do you find the slope between any 2 points? Algebra. So the very first thing we do is we take algebra and we just extend it a little bit, and then you get calculus. Right? Maybe it would be a little more involved than I just made it sound. That's basically what it is. So what do they really want you to do? I'm sorry. So this is where the problem starts. They give you this, and they want you to calculate that for some function they give you. X squared minus 2x plus 3. They want, for this function, they want you to calculate this. So how do you do that?
You plug in a and a plus h.
Yes, so what's f of a?
A squared minus 2x.
And please, dear God, I still have people that, when they ask you this, you just multiply this by a. That's insane. We all know that function notation is all about substitution. Right? What's f of a plus h? plug a plus h in for x, so a plus h squared minus twice a plus h plus 3. And you can simplify that a bit, right? Let me pull this up here. So we got f of a plus h is a plus h squared minus 2a plus h plus 3. And f of a is a squared minus 2a plus 3. So what's f of a plus h if we simplify it? And then distribute that, and then you get that. There, blah, 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 blah. Right? Nothing major there. All right, now you've got the pieces part. So I like the way to do this. You have some kind of large expression that has... So you figure out what that is. You figure out what that is, and then you throw them in. So you don't have everything. You're trying to do everything at once. It's crazy. So put f of a plus h. Minus, this is the thing that people forget. You got to subtract the entire f of a. All over h. Okay, I'm sorry, that was weird. And now, what interesting thing happens on the top? The a squares cancel, right? The 2a's cancel. Negative 2a plus 2a. See that? And that wouldn't happen if you weren't careful. The 3's. In fact, everything that's left, what would you say is the commonality between everything that's left on the top? The L of h, which means you can do what with the h on the bottom?
Cancel
That will always happen with this. Freaky. So I end up with, if I cancel an h out of everything, what do I get?
2a plus h minus 2.
Cool. So, what do we know that means then? I went a little further than this problem. This expression represented the what? Don't say the difference quotient. It represents the slope between any 2 points. And actually, let me see if I'm going to dare to go into calculus right now. We haven't done any calculus yet. We're about to right now. Here's some calculus. Like I just called it, calculus. Let's go calculus. Here's what calculus tries to do, which seems impossible. Calculus tries to determine the slope of a function at a point. Why does that seem impossible? How many points do you need to calculate a slope? You need 2. And calculus says, I want to know the slope at a single point. So physically, I gotta remember my Tuesdays are always so short. Physically, what would that mean? If I was twirling something and I let go of it, that would be the slope at that point. So I'm twirling it around. So I get this circular function. So if I let go of it here, the direction it heads off in, I would call it the tangent. I'm sure you guys, it is related to, tangent. Right? I don't know why. Bosch is a tangent. That would be the slope of it would be that direction it heads in. So as I'm going around, as I'm going around some function, if it was suddenly just to start just going in a straight line the way it's going, then like right here it would go like that, right? Think about it like a roller coaster, suddenly the rules of physics change. You're like, oh, so it's called tangent. It's got to hit that just once. All right, how are we doing? Does that sound? So here's what's interesting. How do I make this become closer and closer to 1 point? I make h get really small. Let h go to 0. And I just don't let it actually get to 0. I just approach 0. So if h were 0 here, this would be 2a minus 2, right? You guys kind of with me? A little bit? And that would be the slope at any point on that parabola. So for example, what is the vertex of this? What's the x value of the vertex? Anybody remember the shortcut? Negative b over 2a, kick x. So what would that be? Positive 2 over 1. Is that over 2? Sorry. Positive 2 over 2, 1. So at 1, it should be what slope? That's the vertex, so what should the slope be there? 0. So when I plug a 1 into there, for a, what do I get? 0. So that, if I let h go to 0, that does represent the slope at any single point on that parabola. It's really neat. So that's the merger between algebra, look, algebra, to this, and then calculus says, now let h get really small. That's where algebra goes, I'm out. Algebra goes, no, I'm out. And calculus goes, come on, man, it's not that bad. The h's cancel. Now that was creepy. Sorry, that was awesome. Now it's some creepy. It's natural. All right, I'm sorry. Oh, well, shoot. I guess I won't get into it. I sort of got into section 2.1, because 2.1 is all about the tangent at a single point. I really want to make this point, though. In chapter 2, there are two things. There is a limit in what it means by itself, and then there is how is a limit used to find the slope at a point. We're going to come back to what I just said, because it's going to get confusing when you do the problems. You've got to be aware of what you're doing. There's a limit. It by itself exists. It can do a lot of shit. One thing it can do is it can be used to figure out the slope. That's just one thing it can do. It can do a lot more than that. And that's enough. All right. So next time, tomorrow we'll get into chapter 2, officially.